In this episode, we're going to look at TCP and UDP communications. I'll show you different parts of these communications, and then I'll talk about the concepts along the way. This activity is to provide a foundation for understanding for TCP and UDP in detail. Simulation mode that we're going to use here provides the ability to view the state of different PDUs as they travel through the network. Simulation mode, once again, enables us to view each of these protocols and the associated PDUs. The steps lead you through the process of requesting network services through various applications that are available on a PC client. We will then explore the functionality of TCP and UDP protocols, multiplexing, and the function of port numbers in determining which local application requests the data or is sending the data. Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. TCP and UDP Communications. Here I have the Packet Tracer Labs already open. On the left side, this is our work area. This is where we're going to interact with our devices. On the right side, the right bottom, I have the Packet Tracer activity window. That's the original instructions that come with Packet Tracer. In the upper right, the majority of the right side, I have the Word document. It's basically what the Packet Tracer activity windows has, but it's a Word document. There's questions in this Packet Tracer Lab. The Word document will allow me to enter in my answers and save them at that point. Getting started, what we're going to do here is look at how traffic travels across the network, how we can have multiple conversations happening with TCP and UDP, and see how this travels, like I said, across our network. Coming down here, first part is part one. We're going to generate some network traffic in simulation mode to view the multiplexing. And once again, multiplexing is multiple conversations happening at once. Okay, first step, generate traffic to populate address resolution protocol tables. Now, to generate this traffic, what we're going to do is we're going to click on our multi-server. The multi-server here is a web server, FTP server. We run a bunch of different services on there to generate the different types of traffics from our different clients. So I want to go ahead and click on multi-server. I'm on the desktop tab. You can see we have two tabs up here. I'm on the desktop tab, and then open up my command prompt. I don't know if you saw it, but I did make this window a little bit wider going left to right. That's just something I just naturally do because the text lays out a little bit better in that window. Enter ping -n 192.168.1.255. Now this is our normal ping command. So we can type in ping, and then they're having us enter in an option. -n, or minus, the minus sign n, and then the number 1. What that's going to do is just send out one ping. The normal ping by default sends out 4 pings. We're just going to have it send out one ping. That's what the -n and then the space and then the number is how many pings you want to send out. And then we're going to ping 192.168.1.255. Now 255, that is the broadcast address for our network. And what's going to happen is this ping is going to go to all the devices on our network, and then the devices will answer back. When they answer back, it's going to build our ARP table, and we'll get to see what their MAC address is based upon their IP address. So I'm going to go ahead and hit enter, and notice I got 4 replies back right away. 4 devices replied back to me and said, hey, I'm here, I'm talking with you. And then I also updated my ARP table. If we look at our diagram here, we have, besides the multi-server that we're on, we have 4 other devices on our network. The switch doesn't count because it's just there to pass traffic, but we have 4 end devices, and that's who responded to us, is those 4 devices. Okay, step 1C says go ahead and close the window. Step 2, let's generate some HTTP web traffic. So switch to simulation mode. In Packet Tracer, you can have either real-time or simulation mode. Real-time, everything happens instantaneously, and typically stuff completes in milliseconds in real time. Simulation mode, you can click it one step at a time. And so if something would take a couple milliseconds to complete and it has like several steps here, you can see each one of those steps in simulation mode. To switch to simulation mode, down here, if you look in the bottom of our main Packet Tracer window, it says real-time and simulation. All you have to do is click on simulation. When you do that, it opens up the simulation panel. And we'll be seeing how that works here in a second. Step 2B. Click the HTTP client. That's the name of one of our PCs over here, HTTP client. Open the web browser from the desktop. So we're on the desktop tab. And once again, I open this up because right now, here is the web browser button you have to click on. By default, I open this up a little bit wider, right and left, so I can see everything. So I click on the web browser, opens up our minimalistic web browser, but it still is one. In the URL field, enter in 192.168.254. 192.168.1.254. That's the address of the multi-server. One of the things the multi-server is doing is it's running a web server. Click go. Now, I'm going to slide this over. Before I click go, notice our HTTP client. There's not a whole lot there. I'm going to go ahead and click go. What it's going to do is it's going to put an envelope here. That is a PDU, and if we slide a little bit over here, we can see some information about it. That's what we're looking at, is we just created this. Now notice it's not going through the network. It didn't go and fly through the network in milliseconds, once again, because we are in simulation mode down here. Going back to our steps, step 2D, minimize, but do not close the HTTP client. Right here, this is minimize. It's the dash line. It's like a minus sign. Go ahead and click that. Do not close that window, because if you close that, then the HTTP PDU is going to go away. On to step 3. Let's generate some HTTP traffic. Click the FTP client. Once again, that's one of our other computers here. Bring it up. Click the FTP client, open the command prompt, open up there, enter FTP 192.168.1.254. Windows typically has a FTP client built into it. It's not the graphical user interface. It's not a GUI. It's not pretty and graphical, but they typically do have one built in. And to open it up, you type in FTP just like you're typing in ping, but now we put in the IP address once again of our multi-server, 192.168.1.254. And notice we are trying to connect. Down here on our FTP client, if you look at it, we do have an envelope, and it is a PDU that we're going to be watching go through the network here shortly. And final step here is minimize, but do not close the FTP client. So I'm going to go ahead and minimize that. On to step 4. Step 4. Click the DNS client, another PC we have in our network. Make the window a little bit bigger. Enter NS lookup. Once again, NS lookup is name service lookup, and it'll give us information on our name services, our DNS server, and how that resolves to different IP addresses. I'm going to go ahead and open up the command prompt, type in NS lookup, and then put the domain name of our multi-server in there. So it's multiserver.pt.ptu. I'm guessing multi-server, well, that's the name of the computer, PT, Packet Tracer, and then .ptu. I'm making a wild guess that that's Packet Tracer University. And so open up our DNS client, type that in there. So multiserver.pt.ptu. Go ahead and enter. And now notice we have another envelope here. It's a different color, and we're going to talk about that in a second. Go ahead and minimize the DNS client window. On to step 5. We're going to generate some email here. first thing, click on email client, bring it over. We'll put it up here. I make this a little bit bigger and open the email tool from the desktop. If we look, once again, we're on the desktop tab looking for the email tool. I apparently have to scroll down. Oh, right here, email tool. I'm going to go ahead and click on that. E, click compose. So I'm going to go ahead and click compose and enter the following information to user@multiserver.pt.ptu. So once again, that was multiserver.pt.ptu. Subject line, personalize that. Packet tracer example, and put a subject in there. Fun with packet tracer. There we go. And then click send. Once again, when I click send, notice we have a PDU that appears over the mail or email client. Go ahead and minimize it. Once again, don't close it, just minimize it. Step 6 here, verify that the traffic is generated and ready for simulation. Now should be a PDU entry in the simulation panel for each of the clients. That PDU is this envelope here. Notice there's an envelope by each one of the 4 clients on the bottom. And so we're getting ready to send some data from the client to follow this process. Step 7, examine multiplexing as the traffic crosses the network. You'll now use the capture forward button in the simulation panel to observe the different protocols traveling. The capture forward button, if we look here in our main packet tracer window, sorted down at the bottom center, this is the capture forward button right here. It's a triangle that points to the right and it points to a line. So it's capture then forward. Step A, click capture forward once, all the PDUs travel to the switch. So I'm going to go ahead and click on that in a second. Watch how the PDUs travel. So I'm going to click it in 3, 2, 1, click. And all the PDUs, all the information is sent to the switch at once. And so now the switch has to process that. And if you notice here, it's got some blue lines or moving blue dots, I guess, on some of the PDUs, and then one doesn't. What that means is the ones with the blue dots, they're in the queue. The one without the blue dots is going to get processed. Step 7B, click capture forward 6 times and watch the PDUs from the different hosts as they travel on the network. Note that only one PDU can cross a wire in each direction at any given time. Only one PDU in one direction can travel at any time. Let's go ahead and watch that. So I'm going to come down here. It said click the capture forward button 6 times. And so I'm going to click it once. Notice how one PDU went up the wire. So in one direction, we only have one PDU going. I'm going to go ahead and click the capture forward button the second time. We had one going up, one going down. Third time. And notice how we have all these conversations. They're moving back and forth, but only one PDU in one direction at a time. They can go, you can have 2 PDUs moving in opposite directions, but you only can have one in one direction at a time. 4, 5, and 6. And so we have our email client. If you notice, they all sort of finish their processes. Question, what is this called? The idea of having these different PDUs moving all over, different conversations happening all at the same time. We are multiplexing those conversations. And so what we typically call this is conversation multiplexing, because we can have multiple conversations at the same time happening. And so, like I said, conversation multiplexing. Variety of PDUs appear in the event list in the simulation panel. What is the meaning of the different colors? Over here in our main packet tracer window, we have our simulation panel. And then we have a bunch of PDUs that have appeared here. And as you can see, the different PDUs appear at different times. They have the timestamps here. We have some that are visible, some that aren't. Typically the ones that aren't have completed their journeys. Now, if we look at the type column, notice the type column here. Why are there different colors? Well, notice DNS here on my screen. Your colors might be a little bit different, but on my screen, I have this cranberry, this dark red color for DNS. And then if I go down a little bit more, I come to another cranberry, and that's DNS. Cranberry's DNS. And then looking up here, the second one down is this light green. And so light green here is the TCP. Light green is TCP looking through here. And down here we have HTTP, which is a purple color. And then at the bottom we have SMTP down here, Simple Mail Transfer Protocol. That's a darker blue. It's a little bit different than the HTTP. I don't know if the recording will catch that, but it is a slightly different color. And so what is the different colors? Well, they represent different protocols. Different colors represent different protocols. On to part two. Part two, we're going to examine the functionality of the TCP and UDP protocols. Step one, examine HTTP traffic as the clients communicate with the server. So we're going to look at HTTP traffic, our web traffic, as they communicate with the server, our multi-server. First step we're going to do is reset our simulation. So over here in the main packet tracer window, we're going to reset this, and so there is nothing, so that there is no save data, there's no PDUs. The simulation panel will be cleared out, and the reset simulation button is actually in the simulation panel. If you go down below all these PDUs, right here is the reset simulation button. This is the button we're going to click, and so I'm just going to go ahead and click it, and notice everything is cleaned up on our work area. On to step 1B. Filter the traffic that is currently displayed to only HTTP and TCP PDUs. To filter the traffic, what we do is click on Edit Filters and then toggle the Show All None button. Down here in our packet tracer window in the simulation panel, at the bottom, we have a button called Edit Filters. But before I click on that, notice it says the event list filters. The visible events are DNS, FTP, HTTP, POP3, SMTP, TCP, and UDP. So we got our domain name service, file transfer protocol, web traffic, 2 email traffics, and then we have our TCP and UDP traffic. What we're going to do is go ahead and click on the Edit Filters button, and then our next step here is it says toggle the Show All None button. That's right next to the Edit Filters. I'm going to go ahead and click on that once. Notice it is unchecked what we had there, and we do have 3 tabs here in this filters window. We have IP version 4, IP version 6, miscellaneous. When I clicked on that Show All None button and we toggled it, it unchecked everything in there. And so what the next step is select HTTP and TCP. Well, HTTP and TCP is not on the IP version 4 tab, not on the IP version 6 tab, but it's on the miscellaneous tab. And looking through here, alphabetical order, there's HTTP. I'm going to go ahead and select that, and TCP. Go ahead and select that. Once you have these 2 selected, you can go ahead and close that out. You can close it out by clicking the red X up here. If we look back down here on the events list filter, it says visible events, and the only 2 visible events we're going to see are HTTP and TCP. On to step 1C. Open the browser on HTTP client. So I'm going to go ahead and open up our HTTP client. Browser's still open from last time we were there. Enter in 192.168.1.254. That's the IP address of our multi-server. It's in there already. Click Go to connect to the server over HTTP. I go ahead and click Go. Notice we now have a PDU at our HTTP client. minimize the HTTP client window. Once again, that's the dash, or sort of looks like a minus sign. Do not close that window. If you close it, you have to reopen it and do that again. But I'm going to go ahead and minimize it. Step D, click capture forward until you see the PDU appear for HTTP. Note the color change of the envelope and the topology matches the color code for HTTP PDU in the window. So I'm going to click the capture forward button until I see a PDU appear for HTTP. What I'm going to do is I'm going to watch here in the simulation pane until I see HTTP appear. So I'm going to go down here, click on the forward capture button. That's down sort of in the center middle of our packet tracer window. I'm going to click it once. Got TCP there still. Click it a second time, TCP. And as you can see, our PDU is traveling through the network. Click it a third time. We're back to the switch again. Click it a fourth time. We go to the HTTP client. And now we have an HTTP PDU appear. Okay, so that takes us care of D. Why did it take so long for the HTTP packet data unit to appear? Well, what had to happen was, if you notice, the first ones that went through, the TCP ones, we were establishing that connection between the HTTP client and the multi-server. We had to establish that connection, and that once we had that connection established, then we can start sending our HTTP, we can start sending our web traffic across that connection. And so our answer to the question here is because TCP must first establish the connection so that HTTP traffic can begin. There we go. Click the PDU envelope to show you the PDU details. And so what we're looking for here is that new HTTP PDU, this purple one here. Go ahead and click it. It's going to open up a PDU information window here. On the outbound PDU details tab, here in this PDU information window, there's a couple of tabs. Now, depending upon where this PDU is in the process, you may have one tab, you may have 2 tabs, 3 tabs. I've even seen 4 tabs place. But right now they want us to click on the outbound PDU. So I'm going to go ahead and click on this second tab over here. And here is how our bits are assembled. It has all of our different header information in here for all the different protocols and the layers of the OSI model that we're passing data through. And then it shows us where our data is. Down here, we're making an HTTP request. And so that's our final data. Scroll down to the second to the last section. What is this section labeled? So I'm going to scroll all the way down. This is the last section. Second to the last section is right here. This is the TCP section. And so what is the section labeled? Well, it's labeled TCP. Okay, I'm going to click back here on the PDU to bring that window back up, outbound tab. Are these communications considered reliable? Well, it's a TCP section. TCP is reliable. Remember, TCP is reliable. UDP, user datagram protocol, that is not reliable. TCP is. So yes, this is definitely considered reliable. And then the next one here, record the source port, destination port, sequence number, and acknowledgement numbers. Okay, so I'm going to go here. I'm going to slide this over so it doesn't hide anymore. We want our source port. If we look at the TCP, here's our header information. And remember, first thing in our header field was the source port. Here we can see our source port is 1026. That is what it's coming from on our client. That is the tab in your web browser. That tab has been assigned port 1026. And remember, what these ports are the the logical layer 4 port numbers. That it's basically just the number in that layer 4 header, in the TCP header here, that says this traffic is HTTP traffic. It is web traffic. And so that's what these logical layer 4 port numbers are. And so we want that as our first number, so that was 1026. Second number is our destination. Right next to the source port is our destination port. We are headed towards port 80. Port 80 is on the server. On the server, there's a server application, and it's and what we say is it's listening for port 80. And what it does is it looks at the layer 4 port and looks at that destination port number and says the server application is set up to listen or identify that port 80 and that destination port. If it matches port 80, then it's for them. And so the web server is listening for port 80. It sees that it is port 80, and it takes this and it reassembles those segments at that point in time. Our destination port here, once again, was port 80. Sequence number, if we look at our sequence number is 1. And then the next field here is our acknowledgement. Our acknowledgement number is 1. Right there is our number. Now, on your computer, your source port might be a little bit different. On mine, it's 1026. Yours, it could be off by 1, 2, maybe up to 10. But it'll be somewhere close to this, within 10, maybe 20. But that number is randomly generated by the web program. Step 1F, look at the value in the flags field, which is located next to the window field. Back over here, looking at our PDU information, we have the flags field right here. Now, as we look at it, there's a couple things that are happening. We have a 0B up on that first line, and then on the second line, we have a 0, 1, 1, 0, 0, 0. What this is here, this 0B is the hexadecimal equivalent of those 6 bits below it. And remember, the flags are 6 bits long. Each of those bits represent a different value or stage in the communication process is maybe another way to look at that. Down here we have a chart. And if we look here, that first bit is a 0. The first bit on the left side is a 0. If we look at the chart, the first bit there is the urgent bit. Then the second bit over from the left, in our example, it's a 1. That's the acknowledgement. Then we have the push and the reset, and then the synchronize, and the finish one. Question is, which TCP flags are set in this PDU? Now, the flags that are set is where there's a 1. So we have a 1 in the first column, and we have a 1, we have a 1 in the second column and 1 in the third column. The second column here is the acknowledgement and the push. So those are the 2 flags that are set. ACK and PSH. Close the PDU and click the capture forward button until the PDU with a check mark returns to the HTTP client. Come over here, close our PDU information window, and then I'm going to click the capture forward button until this purple PDU, it's purple on my screen, might be a different color on your screen, until it comes back to the HTTP client. So I'm going to click it once. Click it a second time. Notice we have that right here. It's moving there through the system. 3, 4, we're back to the switch again. And finally the 5th one comes up with a green check mark. It's got a little green flashing check mark in there. Takes care of GH. Click the PDU envelope and select the inbound PDU tabs. Once again, I'm going to click it. It's the one with the green check mark. Mine is purple. Yours might be a little bit different. And the inbound PDU details. That is one of the tabs here at the top. We have OSI model. We have the inbound PDU. Go ahead and click on that. Question: how are the port and sequence numbers different than before? Well, we're talking about that TCP field, so I'm going to scroll down. Here's our TCP header information. And what I'm going to do is I'm just going to write these values down again. We had the source port, destination port, sequence number, and acknowledgement. I'm going to write that down so that way we can compare them. So our source port right here is port 80. Destination port. Destination port here from our PDU is 1026. We add sequence number. Next field here is the sequence number. That is 1. And our acknowledgement number is 103. 103. Now, I have those documented. What is the difference here? Well, looking here, 1026 and 80 is what we recorded the first time. Now we have 80 and 1026. Those have changed. And so source port and destination ports have switched. Destination ports have switched. Sequence number is the same. Acknowledgement number has changed. We went from 1 to 103. ACK number has increased. Okay, does that make sense? Well, the source port and destination port, those have changed. Because remember, when we sent the HTTP request, we were coming from a random number generated by the web browser, that was 1026, and we were destined to that application that was listening on port 80. The request went to the server got it, and now they have to switch that to send it back because that web browser is listening for port 1026, and so it needs to come back in there. So that is the destination port. Where is it coming from? Well, it's coming from the web server, and once again, that web server is listening at port 80, so that's why they switched. Whoops. Step I. Click the HTTP PDU which the client has prepared to send to multi server. This is the beginning of the HTTP communications. Click the second PDU envelope and click the outbound information. And so right here, I'm going to go ahead and click on the one without the check mark. I'm going to click on outbound PDU. I'm going to scroll down here. And what is the information now listed in the TCP section? How are the port and sequence numbers different from previous ones? Okay, I'm going to record those numbers down so that way we can look at them. Our source port here, once again, we're coming from port 1026. That was the value of the tab in our web browser. So 1026. We are going to destination port of 80. That's on the server, that's on the web server. The web server application is listening for port 80. It's looking for that destination port field to say 80. And so that makes sense. Port 80. Oh, there we go. Port 80. Our sequence number is 103. 103. And our acknowledgement is 234. 234. Notice our sequence number here is what the acknowledgement was. And so up here, this PDU, when it came in, the HTTP one said, I have accepted one less than this, 102, and now I am waiting for segment 103. Well, down here, we are now sending out sending out segment 103 that's identified by our sequence number. And so that's what we're looking for. And then step J is to reset the simulation. Come back over here in our simulation window in the simulation panel. Here's the reset button. I'm going to go ahead and click on that. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. On to part two. Part two, we're going to look at some FTP traffic as they communicate with the server. Step 2A, open the command prompt on the FTP client. Initiate FTP connectivity by entering FTP 192.168.1.254. Coming over here, I'm going to click on our FTP client. That's one of our servers. If we notice we already have this up from our last time, I'm going to hit Control-C just to end it. Give it a second. I did hit Control-C. I hit it a second time and it ended right away. And I'm going to go ahead and re-enter that command in here. FTP 192.168.1.254. FTP.192.168.1.254. I'm going to go ahead and minimize this. In the simulation panel, change the edit filters to display only FTP and TCP. So over here in our packet tracer window, I'm going to click on edit filters. On edit filters on the miscellaneous tab, I'm going to uncheck HTTP and check FTP. And so right now, only FTP is checked and TCP. That's all we want. Go ahead and close the windows, and we can verify that down here right above the edit filters window. We are only listing FTP and TCP. Click the forward capture button. Click the second PDU envelope to open it. I'm going to go ahead and click the capture forward button. That's the button right here. I'm going to go ahead, click it once. Click the second PDU envelope to open it. That second one is still the one on the FTP client. I'm going to go ahead and click it. Click the outbound PDU details tab right there. Scroll down to the TCP section right at the bottom. Are these communications considered reliable? Well, once again, yes, it is considered reliable because it's TCP. And they're designed to give us reliable communication. So yes, it is considered to be reliable. Step 2D, record the source port, destination port, sequence number, and acknowledgement. What is the value in the flag field? And so I'm going to go ahead and type our answers in here. Source port here is, we're coming from 1026. Once again, that's a randomly generated number by the FTP client. It just happens to be coincidental that it's the same as the HTTP client, but we're just going to ignore that for right now. And so we have 1026 as our source port. We have our destination port. Destination port is 21. 21, remember if you remember 21 on the well-known ports list for layer 4 ports, layer 4 logical ports, that was our FTP server. So I'm guessing, or that makes sense right now. Our sequence number is 0. And our acknowledgement number is 0 at that point in time. And what is the value in the flag field? The value in the flag field, we have 1, 2, 3, 4. The fifth column is a 1. If I scroll up to our little chart here, 1, 2, 3, 4, 5. This is the fifth field right here. It's the synchronized field. So the value in there is synchronized, SYN. Close the PDU window, click the capture forward button until the PDU returns to the FTP client with a check mark. So go ahead and close this. Once again, here's our capture forward button. I'm going to go ahead and click on that. And we are watching this PDU, the second one here. So I'm going to go ahead and click on that. Goes to the switch. Click on it a second time, goes up to the multi-server. Click on it a third time, down to the switch. Click on it a fourth time to the FTP client. And now we have a green check mark in there. We have completed it. On to step 2F. Click the PDU envelope and select the inbound PDU tab. I went and clicked on the envelope. Notice we have 3 tabs up here right now. We're on the inbound PDU. Scroll down to the TCP settings. What are our values again? Well, I'm going to record them to start with. Our source port up here is port 21. Oops. Wrong field. That was 21. Once again, it's coming from the FTP application. The FTP application is listening and sending on port 21. That's good. Destination port here is port 1026. That was that randomly generated port that happens to be the same one of the HTTP client, but that was the randomly generated port number for the FTP client, so that was 1026. That looks right. Next value here is the sequence number. Sequence number is 0. And the last number we're entering here is the acknowledgement number, acknowledgement 1. Source and port, or source and destination ports, they've switched because once again, we're now we sent out a request, we're getting a reply back to that request. To get that reply back, you got to switch the source and destination. The sequences, we're still on that first sequence of data. And our acknowledgement is we've got our first piece of data in. Now I'm expecting the second piece of data, which is data segment number 1. Once again, computers start with counting with 0. Click the outbound PDU tabs. Coming back here to our PDU information window, I'm going to move over to the outbound PDU tabs. How are the port sequence numbers different from the previous results? I'm going to scroll down here. And this is now what the difference is between these inbound and outbound. Inbound is the data coming in, the client processes it, and then it gets ready to send it back out. And so inbound is when it comes into the client the first time before it processes. Outbound is after the client processes it and it gets ready to send it out. And so we're looking at the outbound tab here. I'm going to go ahead and record our information again, just so we can compare it. Our source port here is 1026, randomly generated by the client. Destination is port 21. That's a well-known port number for FTP servers. We are looking for our sequence number of 1 and our acknowledgement of 1. Source and destination have switched again. So source and destination have switched. And this time our sequence number has increased by 1. Or increased to 1, we'll say that. And what happened here is we are now sending the next piece of data across there. We haven't got an acknowledgement in that the destination has received it, but we are waiting for that, or we've just sent out another piece of data because we got the acknowledgement in already saying we received segment 0, we're waiting for 1, so we're going to send out segment 1, and that's what the 1 in the sequence field is, but we haven't got any other acknowledgements in. That's why the acknowledgement field has stayed the same. Close the PDU window, click the capture forward until the second PDU returns to the FTP client. PDU is a different color. I'm going to go ahead and close this. Once again, we are watching this PDU, the one that is currently on the FTP client. I'm going to go ahead and click the capture forward button once, moves up to the switch. Click it a second time, it moves up to the multi-server. Gets there, and once again, we are waiting for the PDU to return to the FTP client. Notice the green one has the check mark, but now there's a gray one that's there. I'm going to click the capture forward button, and we've changed colors. Now we're moving back down to the switch, and now we're back to the FTP client, and okay, we're at the FTP client now. I open the PDU, select the inbound tab, scroll down to the TCP section. Here's our PDU information. Here's the inbound PDU tab. I'm going to scroll all the way down. Here's our TCP section. What is the message from the server? And so what we're going to do here is look and see what the message from the server is. We're down here at the TCP section. there's not exactly a message, but if we look at the FTP response, the message says, welcome to the PT FTP server. Welcome to the Packet Tracer FTP server. That's what the message says. And so what happened is when it turned to a different color, when mine turned from light green to gray, instead of being a TCP communication process of establishing that connection, all of a sudden we've now switched. Once we had that connection established, we are now communicating with the FTP protocol, and we have our welcome message. And so the message here is welcome to the PT FTP server. And the last step is reset our simulation. So I'm going to go ahead and close our window and click reset. On to part 3. We're going to examine some DNS traffic and see how they communicate. Repeat the steps in part 1 to create DNS traffic. Okay, so we're going to come up here, scroll all the way up, look at part 1 here where we set up DNS traffic, which was part 1, step 4. We're going to generate some DNS traffic. What we're going to do is click on our DNS client and enter in the ns lookup space multiserver.pt.ptu command, and a PDU will appear. What I'm going to do is enter that in, ns lookup space multiserver.pt.ptu. Go ahead and look at it. We have traffic. But we didn't get a PDU to appear yet because our filter, we haven't changed that. If we go back down to part 2, step 3B, we need to change our filter. So I'm going to go ahead and minimize our DNS client window. Down here, I'm going to click on Edit Filters. On the Miscellaneous tab, I'm going to uncheck FTP, and then I am going to uncheck TCP, and then I'm going to check DNS and UDP. Right here, I'm going to go ahead and click on UDP. But there is no DNS. We look back here on the IP version 4. There we have the DNS checkbox. So once again, on Miscellaneous, everything is unchecked except UDP. And then on TCP, we have to go into there, and that's where we check DNS. And just to confirm, everything on IP version 6 is also unchecked. Go ahead and close that, confirm what we're looking at. Down here, right above where you clicked on the Edit Filter button, it says DNS and UDP. And now our PDU has appeared on the DNS client right there. Click the PDU envelope to open it. Go ahead, click on it. Here's our details. Look at the OSI model details for the outbound PDU. So I'm going to click on the outbound PDU details tab. What is the layer 4 protocol here? Well, as we look here, what we're going to do is we're going to scroll down here. We have Ethernet, that's layer 2. We have IP, that's layer 3. Layer 4 here is UDP. Typically, layer 4 is either TCP or UDP. Right here, we have UDP. So our layer 4 protocol is UDP. Are these communications considered reliable? Once again, UDP is not reliable. It is what we consider best effort. There is no confirmation that that data has actually reached its destination, so it is not considered reliable. And so it is not considered reliable. Step 3E, open the outbound PDU details tab and find the UDP section of the PDU formats. Record the source port and destination port. Why are there no sequence or acknowledgement numbers? And so I'm going to record the source port and destination port. So back here in our PDU information tab underneath UDP, we can see we have our source port here is 1026. Once again, that number is randomly generated by the DNS client. The destination port right here is the second field in the UDP. that is 53. And if we remember from our well-known layer 4 logical port numbers, 53 is the DNS port number. So the DNS application is listening for port 53. The DNS application is looking at that layer 4 header, the destination port of 53. If it's 53, the DNS server application is going to go, hey, that's for me. I'm going to reassemble the segments and process that request. Then the last question is, why is there no sequence or acknowledgement numbers? The reason is that there's no sequence or acknowledgement numbers is there's no guaranteed delivery. Sequence and acknowledgement numbers is used by TCP to guarantee that delivery of data. Here with UDP, it's best effort. And if it doesn't get there, it doesn't get there. We're not going to worry about resending it. And so because UDP does not need to establish a reliable connection. Yep, UDP does not have to establish that TCP connection. That TCP connection makes it reliable. Here, we don't have to establish that. Step 3F, close the PDU and click the capture forward button until the PDU with the check mark returns to the DNS client. Come up here, close the PDU window. Down here, I'm coming and clicking on the capture forward button. Capture forward button moves the PDU to the switch. Click it a second time, moves it up to the multi-server. Multi-server gets it in. The DNS application processes it because the destination port said 53. DNS server is listening 53. Now we're going to send it back out. Click it another time, sends it down to the switch. Switch then forwards it onto the DNS client, and it completes it. We can tell it's completed. It has that green flashing check mark again. Step 3G, click the PDU envelope and select the inbound PDU details tab. I'm going to come over here, click on my envelope with the green check mark. Click on the inbound PDU tab right here. How are the port and sequence numbers different than before? We can go ahead, we can scroll down here. We are looking for the UDP header right here. It's in about the middle of what we have. And so I'm going to record these. Our source port is 53. That's where we're coming from. That's the port on the server. That's where the reply started. Destination port is on the client. I'm waiting for a response with that port number to come back to me. So that's 1026. That was randomly generated. Once again, just a happy coincidence that it matched our FTP client and web client, but it's a simulation. In the real world, it would be a much different number. And then how are those different? Source and destination has switched. Source port and destination ports have switched. There we go. What is the last section of the PDU called? What is the IP address for the multi-server? And so up here in our PDU information window, I'm just going to scroll all the way down to the end. And what we have here is the DNS answer. And this is part of that DNS process. We did a name lookup on the multiserver.pt.ptu, and so that's the name we're looking up right here in the DNS answer section. This is the answer it came up with. It came up with the IP address. So what is the last section called? Last section is called DNS answer. What is the IP address name for multiserver.pt.ptu? Once again, that is in the DNS answer section. That is this field right here. IP address of 192.168.1.254. And finally, click reset the simulation. Go ahead and reset it. On to step 4. Step 4, examine email traffic as the clients communicate with the server. Repeat the steps in part 1 to send an email to user@multiserver.ptu. I'm going to go ahead and scroll up here to part 1. Part 1, step 5, generate email traffic. So I'm going to go ahead and click on the email client. Our email program is still up, our mail browser. Click on compose. It has nicely saved our information, but once again, you can still go ahead and enter it, user@multiserver.pt.ptu. Put in a subject here, packet tracer example, and put in something in the body of field. I just put fun with packet tracer. At this point, go ahead and click send. It sends it off. I'm going to minimize the email client window. Scroll back down to where we were in part 2, step 4. Step 4B, in the simulation panel, change the edit filters to display POP3, SMTP, and TCP. POP3 is the post office protocol that allows you to get mail from the server, and SMTP allows you to send email. Down here, I'm going to go ahead and click on the Edit Filters field. On the IP version 4 tab, I'm going to unselect DNS. And then on the Miscellaneous tab, I'm going to come over here, select POP3. Right there, couldn't find it. And SMTP, right here's SMTP. Uncheck UDP, and then check TCP. So everything should be unchecked on all the tabs except for on the miscellaneous tab we have POP3, SMTP, and TCP. Go ahead and close that window and verify it. Once again, right above the Edit Filters button, we have, it says POP3, SMTP, and TCP. And once we've done that, notice our PDU has appeared above the email client. Step 4C, click the first PDU envelope and open it. Well, I only have one, so I'm going to go ahead and click open. Click on the outbound PDU details tab and scroll down to the last section. What transport layer protocol is being used? Last transport layer, layer 4, is we are using TCP. TCP. Are these communications considered reliable? Yes, they are considered reliable because we establish a connection. We have a mechanism to guarantee the delivery. If delivery is not met, we resend data. So yes, it is considered reliable. On to step 4E, record the source port, destination port, sequence number, and acknowledgement numbers. What is the flag field value? Okay. Looking here, we have our source port. Our source port, again, is a randomly generated number by the email client, which here is mine is 1026. Yours could be different because there's a little randomization in there. Destination port here is port 25. If we remember from our well-known layer 4 logical ports, port 25 is for our email servers, SMTP servers. Sequence number of 0. We haven't sent any data yet, or we're sending our first piece of data, so that's at 0. We have got no acknowledgements back. First piece of data we're sending out, so there was nothing to receive. So our acknowledgement is 0 at this point in time. Close the PDU window, click the capture forward button until the PDU returns to the email client with a check mark. Okay, here's our capture forward button. I'm going to go ahead and click on it once, moves to the switch, clicks the second time, moves up to our multi-server, third time back down to the switch, and fourth time to the email client, and it has a green check mark. This is the fourth time we've done this. What we're doing is we're establishing our TCP connection, our reliable connection. That's what the first steps we're doing. And notice, if you look at all the PDUs here in our simulation list, that was all TCP traffic. we are establishing that TCP connection. And then once we have it established, then we start sending out SMTP. Click the TCP PDU, that's the one with the green check mark flashing. And the inbound, so looking at that PDU as it comes in to the client from the server, scroll down to the TCP information. What are the port and sequence number? Why are the port and sequence numbers different than before? Well, I'm going to go ahead, I'm going to record them. Our source port is 25, destination port is 1026. 25, destination is 1026. Sequence number is 0 and acknowledgement is 1. And so how are these different? Well, the source and destination has switched. The sequence number is the same because we've only sent out one piece of information. We haven't sent out any more to establish that TCP connection, but the acknowledgement has increased to 1, and so ACK has increased to 1. And the reason that it increased to 1 is we're getting the confirmation. We got our first segment, then that segment was to establish our TCP connection, and we are now waiting for the next segment, segment 1, because remember, computers start counting with 0, so we're waiting for that next segment. Click the outbound PDU tabs. Once again, we're still in that same window. I'm going to move over, click the PDU outbound tabs. How are the port numbers and sequence numbers different than the previous one? Scroll down to our TCP section again. Here's our information. I'm going to go ahead and record that. Source port here is 1026, destination port is 25, sequence is 1, and acknowledgement is 1. How is that different? Once again, we are now sending it out, and so that 1026 is our randomly generated number on the client. We are going to a well-known port number on the server for our mail server. So the source and destination has switched. Now we're sending out the next piece of data. We are sending that next piece of data out because our acknowledgement in the previous, when it came in, was saying, okay, I got segment number 0, I want segment number 1. That's why the acknowledgement's at 1. And so this time what we're doing is we're sending out segment number 1. And so the sequence has increased to 1. There's a second PDU of a different color that the email client has prepared to the multi-server. This is the beginning of the email communication. Click the second PDU envelope and click the outbound PDU details. And once again, here, the second PDU is the one with the dots that are moving on there, basically saying it's in a queue waiting to get processed. So that's the one I'm going to click on. Mine's is purple. Yours could be a different color. And then click on the outbound PDU details or PDU details tab. How are the port sequences and numbers different from the previous 2 PDUs? I'm going to scroll on down to our TCP section, source port, destination. I am going to write that information down here. And so source port is 1026, destination port is 25, sequence is 1, and acknowledgement is 1. And so how is that different from the previous 2 PDUs? Well, it matches the very last one, the outbound one, but the one before it, the destination and source is switched. So they're switched, and our sequence is increased by 1. Here we go to the next question. What email protocol is associated with TCP port 25? TCP port 25 is the SMTP server, the Simple Mail Transfer Protocol server. So it's SMTP. Once again, that is responsible for moving email from your client to the server, and then from your server to the destination server. And then what protocol is associated with TCP port 110? That would be POP3. POP3 is the post office protocol, and that's responsible for delivering the email from your email server to your client. And so SMTP you use to send emails to the destination email server. POP3 you use to retrieve email from your server. That was Packet Tracer Lab 14.8.1, TCP and UDP Communications. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.